OT. Okay, that's a design of bund cutter for paddy cultivation. Mrudulata Deshmukh.
Yes, sir.
Okay. This will going to be a beautiful finishing for
Yes, sir.
yeah, good. That's it.
Good afternoon, one and all. Myself, Dr. Mrudulata Deshmukh, working as a senior scientist in All India Coordinator Research Project on Farm Implements and Machinery, Dr. PDK Akola. So the topic of my presentation is design and development of bund cutter for paddy cultivation. Now, in the cultivation of paddy, the bund of the field it plays important role, and as the seepage loss is more from these bunds, so this bund should be cut properly and it should be compacted so that the seepage loss from this bund is reduced. So traditionally, the bunds are cut with the traditional methods. Next, please. Next, please. So, previous one. These bunds are actually in traditional methods. They are cut manually, and average skilled person can trim and plaster 90 to 120 meter of bund per day. So, there is a need to mechanize this bund making process to strengthen the existing bund ridge and without damaging the height of the ridge. Next one. So the objectives of this study were to design the bund cutter for paddy cultivation, to develop the bund cutter as per the design, and to evaluate the performance of newly fabricated bund cutter. So the picture shows the traditional method of bund cutting of paddy field. Next, please. So this is the methodology how the bund cutter equipment is designed. So power requirement was calculated, and selection of power source was done on the basis of this power requirement. So it was designed for a medium range tractor, that is 35 to 45 HP tractor. So most of the farmers, they are using small tractors nowadays, and that's why this bund cutter was designed for this low HP tractor, that is 35 to 45 HP range tractors. So again, these are the calculations for drawbar pole, width of the implement, and unit draft. And next, please. So these are the pictures for the design bund cutter, hitching flat, symmetric view of the main frame, and side views of the frame and the cutting disc. Next, please. So this is the isometric view of bund cutting equipment. It has two discs and at two edge corners of the main frame, and there are 19 number of pegs in between these two discs. Next, please. So these are the specifications of this bund cutter or bund cutting equipment. Power source is 35 HP tractor, length is 280 centimeter, width 50 centimeter, and height 71 centimeter. And the cutting disc has the diameter of 35 centimeters with the thickness of 4 millimeter. Total weight of the implement is 115 kg. Next, please. So this is the performance evaluation of bund cutter in the field, in the puddled field, and the below picture shows the previous field view before operation and field view after operation with the bund cutter. Next, please. So this is the performance of this bund cutter, showing the depth of cutting and operating width of the bunds, and the performance was carried out with the three range of speed of operations, that is 1.5 km per hour, 2.5 km per hour, and 3.5 km per hour. And the fuel consumption, it was lesser in case of 3.5 km per hour speed, and it was 2.71 liters per hour. Next, please. So this figure shows the field capacity, that is theoretical and effective field capacity at three different speeds of 1.5, 2.5, and 3.5 km per hour. Next figure is of effect of travel speed on field efficiency. So field efficiency was higher again in case of third speed, that is 3.5 km per hour, which was 84%, and the lowest was in 1.5 km per hour, 75.41%. Next, please.
Higher speed because it seems to be increasing with every speed.
Yes, sir.
Okay,
The
that's okay. Go ahead.
So this is the field performance of this bund cutter at different speeds with the bund cutting efficiency of 84% in 3.5 kilometer per hour, and cost of operation was 551 rupees per hectare, again in the higher speed, that is 3.5 kilometer per hour. Next, please. So these are the conclusions. Average operating width was 14.27 centimeter and depth 29.48 centimeter of operation was maximum at a higher speed of operation 3.5 kilometer per hour. Wheel slippage was 28.07, 22.68 and 17.37%. Again, it was lower in case of higher speed. Fuel consumption was again noted lower in case of 3.5 kilometer per hour, and the cost of operation was again 551 rupees at the higher speed of 3.5 kilometer per hour. Next, please. Next one. Okay, thank you.
Thank you. Can I request? Oh,
He was a member. Excellent member. Yeah, industry man. The industry people cannot share their kids.
I was the question.
The industry people.
Okay, sir, I will answer first and then I will present this.
Trying to her.
Ah.
Okay. Thank you.
The industry people, it was good.
Thank you very much. Madam,
Yes, sir.
I think I have a very simple observation on many data tables. Please, when you calculate percentage of something and you are giving figure in rupees, don't give Paisa figure of 73 and
Fraction figures.
79 and all that. Round it off to, because rupee itself is so small.
Yes.
Because you have to look at what is the importance of that, what is significance of that. जब एक रुपए में कुछ नहीं आता तो एक पैसे में क्या आएगा, है ना? So
computer point में
no, but you can always round off.
Yes.
This is your objective. Similarly, many efficiencies people calculate up to second place. And every efficiency, every calculation, every reading gives you different efficiency. But then you still give to, so please put it a round of figure which is, now I saw the, somebody was using the waste loss, okay, like Bangladesh. It's easy to talk.